Good morning. Be live here. That's working. Hi. Two things to work on today. Okay, so still have the drone stuff to figure out. I don't think the experiments went super great on this overnight. I didn't really have time to queue up stuff the way I wanted to. I don't think it was great. I kind of don't want to spend a whole bunch of time today just fiddling with the drone stuff when I think it's mostly a problem of automating the experiments at this point. It seems like it should be pretty stable. Like, let's see what happened to this guy here, right? Drone 10 bill. And got all these like weird jumps in it, right? Yeah, and then this perf is kind of weird. I think it crashed actually, because this looks like, yeah, this is only a 3 bill. It must have crashed. That's a bit annoying, right? Yeah, you can see we have nans in here. And we've seen this before in a lot of different ends. So I don't think this is a bug. I think we just have some stability stuff that we need to prove. And as you get longer and longer runs, right, larger and larger experiments, you run into these edge cases way more often. I think what the best way is to approach this. Like, I kind of want to just run an automated sweep on this and work on other stuff for a bit, because I do think that there are hyperparams in here that should just solve it, right? But we do end up getting nanned out on a lot of them. Like, fixing the nan thing is going to actually be... That's like something I'm going to do in the next big engineering task, because that's actually going to be a fair bit of work. I might just give myself like a small budget of time to mess with it manually just for a little bit. If I can get something stable. I think that's going to be best option here. Like, if I do this, their starting point, right? We like fit this to the neural. Start here, and then we'll see if we'll do 2 bill. 10-minute experiment is not ideal, but terrible. Use this time to start sort of thinking about some other stuff in the process. Another day, another M script activate. Well, I guess when we do use M's, we have UV, so it'll be a little different from that, but yeah. There's a whole bunch of new stuff I want to start on, to be fair. We're not just going to do drone things all day today. I'm going to give myself a little time to just fiddle with this a bit, since Seems like for whatever reason on this specific end, we have more instability when running automated experiments. We tend to like crash some stuff. But after this, we've got stuff to do on meta, which is this like grid-based kind of factory-esque env. Need to get like some basic things running on this. Uh, Later in the week on that, have a head start. Welcome to the folks on YouTube. I have a couple of new projects. Well, I actually have several new projects in mind that would all be like relatively simple to get started on. Like at least wouldn't take a huge amount of time. Um, the project in material science, I just started discussing with a material scientist at Stanford yesterday. I think would be very cool for research. Stuff we can do in robotics. I've started like looking into how we would do our own 60OF arm sim. Do that. That'd be a little bit of math, but it would not terrible, I think. And then there's also this power optimization problem. There's a lab that would be very, very happy if we gave them an sim for that. Lots and lots of applications to. Really, the main bottleneck at the moment is just how many meetings I've got. Kind of getting my mind out of the dev swing. Awesome to catch you live. Just started recording my Hearthstone clone to Puffer. Oh, that's awesome. So let me show you something. I don't think we ever uploaded the. There's probably an open PR for this. I just haven't merged. It's Noah in the Discord that helped us. I did the initial bit. Okay, so there's this Magic the Gathering style clone here. And we have some good ways to design this so that it's useful for RL. So like you can play a land, you can play a 0-cost 1/1. Pass, or you attack, you swing, block, play my land. I play my 2-mana 3/3. That's all I can do. Attack phase. So on and so forth. We have like really good ways to set this stuff up for RL. If you want to chat about that at some. I think the very important thing to getting it to work is going to be to, as much as possible, just make it like the whole UI of this. I'm literally just pressing the buttons 1 through 9 and enter. So I've gotten it down to a very small number of button combos to take all the actions. That makes a big difference. Okay, so we are still stuck on 3 or whatever. Go check the graph. The episode return here and the perf. Not super great. I'm gonna start getting meta set up. I'm trying to remember. I have to do this on the remote, right? Gotta do this on the remote. Is it worth be having a sort of OCR technique to the cards? For the number. Definitely don't want to be doing like from pixels Hearthstone. Yeah, that's gonna be terrible. You don't like if you're building the sim, you don't need to do that, right? Because like just have the numbers in the sim and you can observe them directly. once you're talking about doing OCR on pixels, you've lost by about 5 orders of magnitude in speed already. You see this number here. This says that it's doing 3.1 million interactions with the environment per second. That's training on 3.1. So if the drone is, I think, what are we doing? Hertz or 50 hertz or something like that. Let's call it 50 hertz even. So that is what? 1,000 seconds, I believe, of data. Second of interaction. 1,000 seconds per second. That is almost 20 hours of data. For like 17-ish hours data every single second. A lot of data. Actually, you just divide this number by 50, right? You divide by 50, you get your, what did I say, 60? Yeah, 60,000. So it's running at 60,000 times real. Learn its physics engine. Learn physics engine. If you want to learn the physics engine itself, I've seen some stuff in this area. I don't know if it works generally. So the thing with RL, right, is as long as you actually have access to fixed simulator dynamics, randomize, it tends to be self-correcting, right? So like rather than the drone, and this is the thing we're going to try to get as well. We're going to try to set this up so that rather than having errors between the sim and the real world accumulate, agent's actually going to be self-correcting, right? Such that if its actions don't produce exactly the effect that it desires, it will see that instantly, automatically correct course. That's the really cool thing that you can do with RL. And we actually have some decent evidence. Um, the problem is when you replace the sim with an approximation of the sim that like fails in like qualitatively quite different ways. I don't know whether you get that same thing or you get the opposite, which is errors compounding X. Definitely don't want that one. Exponentially compounding errors is very bad. You guys are doing practical. We're trying to be practical here, right? I mean, this is it's a research lab, but we're not doing research just like to make ourselves feel clever, right? We're trying to actually solve problems with it. High performance sim in general seems like a good tool, like a good investment, right? Being able to learn from large quantities of interaction data, like a very good investment. And we're sort of just spiraling out into different application areas, looking for problems that, okay, we have this core fundamental tech, what can we solve? Mostly how I look at things. I'm trying to think what I can do about this drone sim not working amazingly well. Could it just be the data ratios? It could literally just be the ratios, right? Well, let's actually at least have. Let's see if I can get them to like not racing. There's probably just some stuff we can. That's that's not any good. Did rings past go up? Hang on. Oh, you know what? This actually did kind of go up. Let me at least eval this locally because this might This might kind of be worth something. Get rid of this. All right, so here is the racing policy. It looks good. Here's our like go to wherever policy. Kind of drift around and do your thing. Like kind of a thing, but it's not brilliant, right? How about the flag? The flag is like a really visually obvious one when it works. Yeah, really not doing it this side. Okay. Well, we'll play with this. Definitely play with this. We're gonna use the flag task for the test. Doing land robots, not flying yet, but carrier. Well, we're starting with the air ones because we don't have to do contact sim. Just like way easier. People have asked us about like quadrupeds. I don't know. I think we could probably eventually do quadrupeds. I think I'd be more interested though in like a 6 degree of freedom arm would probably be ideal. Actually, I gotta ask a roboticist why all the arms are 6 degrees of freedom. Like, what can you do with 6 degrees that you can't do with 4? Is it like 1, 2? Is it 2 joints on a 6 degree arm, or is it 2 joints on? Yeah, no, it is. It's like, is it 3 joints? Yeah. Oh, it's because you can't do wrists, right? It's because you don't have the ball socket for a wrist that you have to do it. Quad spiders doing wrestling is good. You have like physical, you have it on real hardware doing wrestling. That's cool. You try our RL stack. Like our RL is probably just gonna be way simpler and faster. The stuff out there. Plus, we have our own algorithm, right? Be better than whatever PPO implementation. Let's get him to flag. Virtual sim, okay. Not that far off from what we're. Yeah, definitely try our algo then. See if it just works better for you. Yeah, let's get the flag while I'm chatting here. Let's get the flag baseline. I'm gonna start messing with this. I think that there are like some things I want to tweak with collision. My first time seeing this is taking inspiration from nature. Um, the inspiration is very loose at best, I would say. It is sort of in the sense that you have very local rewards that produce global behaviors, I suppose. I have a lot of material on RL for beginners on my X articles tab. And so at least now we have a decent dev cycle, right? This is like 1 minute. We're just gonna go off of perf. Might have to up the learning rate. See. So the thing that I want to mess with here. Yeah, see, it's a multiplicative reward. Probably bad. It does end up learning this pretty well, I think. 94 with a 1.4% collision rate, right? See if this changes anything. Just I sort of realized there's a bit of an issue doing it before. Hey Akarsh, what do you think about gold medal IMO? Yeah, that's kind of crazy. I don't understand how it is that they have IMO AI before they have AI that can do any of this super basic programming that I do for all of this. But somehow we live in a world where we have gold medal IMO AI that like can't do basic autonomous programming. The goal code, yes. I've been meaning to read your paper with Ken, by the way. I have not gotten the chance to. I really should. But thing is, like, math is not. Maybe I'm wrong. Maybe I put it on too much of a pedestal. But math really isn't that structured and narrow, right? It really is this crazy, crazy search and exploration task, isn't it? I mean, heck, like writing the code is not. It really requires not that much creativity. What I'm doing here, right? Like a lot of stuff is just like keeping things simple and not trying to make yourself feel clever at the expense of writing bad code. Oh, hey guys, I just made it way better. Yeah, there you go. My rewards were dumb. 97 and 1%. Right, that's like a pretty solid improvement. Wanna like let's see real quick how this looks. 200 million steps, so 1 minute for flag behavior. And if you wait around a second at Karch, we'll show you drones forming in a American flag. Been having fun with these. I'll read your comment once you get this thing. Okay. Copy. I think I have to switch the task on. This is, yeah. They're only trained on the flag task. Okay. Not randomized. To be fair, these are like all sorts of different shaped drones. Kind of hard for them. Hover nice. This doesn't look quite as good as it should, though. I think that I didn't fully. Oh, you know what it is? It's that I didn't change the reward. So yeah, I gotta commit it to get it to look exactly this. I like the paper, but it implies a lot of things for neural applications learned by SG. Does it actually imply a lot of things, or is it like imply that the old theory is bad? I will have to go look. You do this every day? Pretty much. I do take days off occasionally. I also have meetings that I don't stream. My dev I stream, yeah. I should actually make this work real quick because this will look really cool if I commit it real quick. I wish I had my high-end local box. I should probably just buy another one. Bought so many damn desktops. Kind of sick of setting new machines up. And hang on. Plus. Our paper basically says optimization creates messy neural representation on policy and all. Everything is kind of like slightly off policy. Messy. Their work like that literally the more you optimize the better the representations get, more compressed they get. Sentiment neuron stuff and stuff, like interpretability work. Not too much creativity, I think. What, me saying that there's not much creativity in a lot of the sim work I do? I mean, the creativity came from like how to set it up the way that it's now easy and straightforward. It's not that bad at the moment. Generational. Oh yeah, this is way better. Okay, so here we go. There's your flag. Keep in mind the drones are all different sizes, so they all control differently. But yeah, that's a pretty clean American flag. if I give it the exact same drone for all of them and it's like a perfect flag. But yeah, this is, and you can see they self-organize. This is trained in 1 minute, right? Yes, it's shared weight. So that's the tricky thing, right? It's shared weight, but if you look at the drones, look, do you see how they're completely like some of them are bigger, some of them are smaller? They have all different weights, inertias, all sorts of different parameters, and the agent can't see these parameters. So basically, the agent has to do online system identification in the weights of the in the latent space of LSTM in order to do this. So it's like dramatically harder to do this than it is to do it for a single drone. I'll show you the difference if I just do it for a single drone, with like how easy it is by comparison. It's like implicit meta RL, I guess you could say. We're just doing this for robustness. But here I'll show you the difference. I mean, this is just the type of stuff that would like never work correctly before, when things were slow. But now it kind of works with stuff being fast. Let me get you this. Take like 1 minute. We had like what 96.7 before, like 90. You can also, so I have it working now that you can have the drones do a ton of different formations with one policy. All the drones do different formations, or you can have the drones like race. But I can't yet get them cleanly racing and doing formation. That's the next thing. One policy just does all drones. Yeah, I've known about that for a bit, Akarsh. That'll be good. I want to steal him for some NetHack work. Officially starts. Okay, so the collision rate is down like about half of what it was before already. Perf is a bit higher as well. One drone. Let's see what this looks like. I think it should be pretty clean. Takes ages to train. The minute too long for training for you? With anything other than Pufferlib, this would literally take over. You'd have to overnight this. I could probably optimize the dev loop quite a bit more, to be fair, and I should put the time in to do that. You can only spend so much time optimizing the dev loop. Alright, so here is... Yeah, look, way cleaner flag, right? This is basically spot on. Like a school of fish where they try to avoid each other as well. Like when one of them gets out of place, they all kind of shift around it a little bit. Like this guy was like, "Hey, get out of my way. What are you doing? You're in my spot." Yeah, Magnus. Okay, I mean, so this just works. I actually am kind of happy that like it's not fully perfect because you can kind of see like this guy doesn't know what to do because this guy's in his spot. This guy's probably doesn't know what to do because this guy's in his spot. So it's like a school of fish. Now this guy's like they only see local neighborhood. They see their goal and they literally only see the nearest drone to them. They don't see very much at all. Back to the randomized variant that's actually like hard. Okay, I mean, so based on this, the full task again, maybe. Not quite the full task. I think we do this one. Oh, yeah, I know, right? You see the neural MMO3 policies, though, Akarsh? Because you've seen the neural MMO3 stuff, like, basically, there's almost nothing I should be able to do that's surprising at this. Like, that's a crazy policy. I think it's just nearest. It doesn't really matter, though. It's like a two-line of code change, one or the other. This is probably not trained for long enough here, is my guess. For all these tasks, we'll see. In low 90s, good though. Collisions, higher. Oh, 3% collisions. Okay. So this is the multitask setup. This is training the drones for a bunch of different formations. I'm not expecting this one to be amazing because all these different tasks and I didn't train for any longer to compensate, right? We can absolutely train this for longer and get something better, but I just want to test if the changes that I made actually help over. I think we should get at least set up. Will does. Oh yeah, there's a guy I want to chat with about Pokemon follow up research. How many messages I missed? All right, here we go. That runs now. Okay, so this go diffuse task. This is fine. The hover in place task. Mostly hovering in place. A little bit off. A little bit off, but most. Nice. Definitely way better than the racing model, because this is like pretty close to a sphere, right? Follow task, here's cube. They form a cube. Like a cube. Hey, that's pretty close, right? This one. This one's hard. Oh yeah, though, it's like it's kind of getting it. Like, look at these ones. They're like starting to do the Congo. That one's a tough task. I kind of want to train that one on it just to see. Here's the flag. So this will be the good comparison for us. So this is like, you can see this is a little bit worse than before because we've trained on all these different tasks, so it doesn't have enough data for this. Really not that much worse. Like a little bit jiggly. That's kind of it. So pretty happy with this. I think for my taste, this is like, what's this? Like go in a ball, I guess. Pretty good policy. Let's see if we can do the racing one now. We're going to make this slightly longer to account for the racing task, but not massively longer. I do like this. Okay, we will rebuild, and I'll do let's do like 400 million steps. In practice, these things suck up a ton of data. In theory, we should just be able to do like 400 mil. It should be fine. Terminal's frozen. Lovely. I'm really interested in characterizing all M's which have local interactions. Local rules. All possible. You have to be a little bit careful, Akarsh, because if you don't like, if there's not at least some structure, then you're training on random MDPs, which is random noise, and you can't really compress random noise. There has to be some notion of all reasonable M's or something like that, right? If you're willing to do like all reasonable M's, then come on, like just start implementing over here. No idea what's going on. Sorry, presentation on neural MMO. Start learning this. Where should I start? Thank you. That is my PhD defense presentation that you saw. Here, I will link you. There, we do have resources for beginners now. People kept asking me for them for so long that I just went and I actually made some. My articles tab. Got the quick start guide. Got the ultra opinionated guide to reinforcement learning. There's the more general intro guide. Only structure is local interaction. So you just want to like fit some small update rule. This is like the cellular automata thing that you were doing before, right? I mean, you can go ahead and try it. Like, stuff is so fast now that things that didn't work before probably work. And our algorithms have just gotten better. So, what are your thoughts about paper talking about how RL with randomware works? That's some janky language model thing. That's absolutely not true generally. The closest thing that we have to like some janky random thing doing stuff, like RND, random network distillation or whatever, and that relies on the fact that like random convolutions still give you image priors. Not really random. Also locomotion. Random rewards or random goals? I don't trust any of this stuff, honestly. Like, I'll look at a paper if you want to link something quickly, but I kind of just assume all published research is wrong by default because it's like I'm right 80% of the time. Just that. What machine are you using to train in less than a minute? A MacBook takes 3 hours. With Puffer? It definitely shouldn't take 3 hours with Puffer. If it takes 1 minute on my machine with a MacBook, it should take you anywhere between 5 and 20 minutes. Not take 3 hours. M4 would probably be like 10 minutes. Percent? Wasn't this literally... This is legitimately better than before, isn't it? I've never seen 86% on this task. Wait, but there's no rings passed. Hang on, did I do something wrong? Rebuild. I'm confused. Something wrong here. Have rings passed? Hey, PPO steps can you get in that hack? Billions. Ring saturate. Oh. We haven't tried that hard at Karsh because we basically need to go mess around with the way the multi-threading works and the architecture and stuff. I think you get environment bottlenecked until we do a little bit of engineering, which is the main thing that we would have to do with that. Um, if we can make it faster, my guess will be we can't solve the game for sure because you need external knowledge to solve the game. Um, but I think we can do a heck of a lot better than the current benchmarks. Because like billions is not that much. Even if we can get billions, so Neural MMO 3, we did 640 billion and we didn't saturate it. And NetHack is harder than Neural MMO 3. Realize the paper's regards to offline. Well, offline RL is just not RL. It's just not RL. Supervised learning. Survival instinct, offline RL. None of the normal authors. Like the simplest possible task. locomotion thing. Oh, are they doing a thing where just like if the rewards are positive, for instance, have a survival bias, because you get more total rewards if you survive for longer. So that's not like that the rewards are wrong, it's that some of the rewards are wrong, I guess. Yeah, okay, I'd believe that. But the thing is, like, the only reason that it trains at all is because the task is trivial. Like, you can't give it wrong rewards and have it solve anything that's, like, tough. They're not robot. These are, like, yeah. These are not robotics tasks, are they? What are these? No, these are actually. Hang on. Right, but they have demonstration data because it's offline. So that's still trivial with demonstration data. It's hard online. Yeah. Yeah. Okay, if I've interpreted it correctly, then yeah, okay. That's kind of true. But it's not like the result that's like, oh yeah, you can just train with wrong rewards. They completely randomized. I'd have to see if there's a bias though, because they talked about length bias. And like because you have a term state, um like let's say you have positive rewards, then it's always better to just survive for longer. Offline RL does not scale at all. What do you mean doesn't scale at all? Like it doesn't get outside of the data support, right? Is that what you mean? Yeah, it doesn't get outside of the data support, at least not by much, which is why it's just dumb supervised learning. Why, like, oh yeah, we can do offline RLs, kind of stupid. Just supervised learning. Okay, so I had just forgotten to recompile it. This is still better than before, though. That's like a few percentage points better than before and in way less data. I think that there's still some stuff we can. That looks a little better than before. Not like a good sphere, but at least like they've got some intentionality to them now where they actually like go to the targets quite quickly. It's only 400 million steps. That's like not terrible. Okay. Progress. Keep in mind, this is also training on racing at the same time. So like half of the data fully is racing data. It's like a very weird task distribution. Try to eat broken glass and read papers all day. Now it's fun to read. Yeah. I mean, reading academic papers is basically. Okay, that's actually a recognizable flag, which we did not have before. So, and that's progress. Again, this is a very, very hard setting here we're doing because it's mixing in race data. Like, let me see if I can show you the race data. Oh yeah, it's not even doing the race data on this. You can actually see the racing policy. Q-learning is not yet scalable. Wait, Q-learning is not offline. Q-learning is off-pol. Wait, what? I think bias is the... Get the bias from generalized advantage estimation. Get bias to a specific horizon. Yeah, the strict one step is really stupid though. Correct. Um, it's not strict one step though, because Rainbow, like, they do like 3 or 5 step. Still dumb. Yeah, like this, some of these problems are just trivial. Oh, I guess it's a humanoid, which is like a pure robotics only benchmarks is also not a great way to do RL. Okay, 1 billion is not near infinite data. 1 billion is small. You think 1 billion is infinite because your simulators are slow as fuck. Sure, the datasets had sufficient coverage. Don't know how you did that. But like, if you do vanilla Q learning, it's just a bad algorithm. That's like comparing to reinforce. Oh, but they also did SAC. Okay. Huh. 1000x larger than typical dataset. Yeah, this is you guys just trolling. Like, if you're trying to do RL with like a million observations, you're just being dumb. So, like, this blog post is fine so far, but like, the context for this is a lot of the off-pol work, like, or the offline work trying to do anything with a million data points is just stupid. Stop improving at all after billions of steps. Well, this almost seems wrong, right? Like, can't possibly go down. Yeah, so horizon reduction does work. The thing is that we kind of can just solve RL with very long horizons anyways because we're fast. Hierarchical? What hierarchical methods is scalable off-pol? your thing is they're conflating offline and off policy a little bit, right? It's like fundamentally you do need fresh data when you don't have expert data. You will always need fresh data because your stupid policy can't collect good data, right? Yeah, their scaling curve definitely shouldn't go down a little. That's sketch. Hey, Sahil. Welcome. Are you one of the people who've messaged me who I haven't replied to yet? I've been meaning to get to all the DMs asking for meetings. I have a lot of them in the last couple. I think this is a red herring, honestly. I don't know if I agree with this conclusion at all. Like, the thing is that all of RL is slightly off policy. Pretty much the only thing that you really want from off policy is you want the ability to reuse old high quality data. But that doesn't mean you don't want to stop collecting new data. You want as much fresh data as you can possibly get, and then you want to like compute fill basically while you're waiting for new data. You want to fill with high quality old data. No, just saw some stuff in my slide feed. All right, cool. Representational learning doesn't learn a good rep. Bad policy, but we have on policy working very, very well in the high data regime now. I mean, the proof of this is just stuff that we've shown here. Oh, hey, Kevin. They got feedback from Kevin on this. Then. Interesting post. Yeah, I don't. Horizon reduction is basically like make the problem simpler, is the thing. Because like the techniques that they have, they're like n step and hierarchical and stuff. Like you get a certain amount out of those, but at some point it's like the really long horizons are not really amenable to algorithmic horizon reduction as far as I've seen. There might be a way around it. You definitely don't want to have all your tasks be robotics like this. On the paper. All right, cool. Not a good scale. Yeah, I agree. I mean, I will say on the research side, the thing that we are most interested in doing next is at least some form of semi off pol. Basically, but I think people are looking at it kind of wrong, right? So you want to have is you don't want to have like all these fancy algorithms, right? You want to have an algorithm crank up all the data. You have unlimited data. You can use as little compute as possible. Or you want to be able to crank it the other way and use less data with more compute. And you want that to be like a clean trade off with the simplest algorithm possible. That's what you want. Chunking has been crucial. Yeah, it's because you guys have no data though. They're bragging about their 1 billion samples that they've collected. Like, okay, here's 400 million in 2 minutes. We have 640 billion that we run on one. We run this on one server. We've done 640 billion observations online as well. So like, right? Correct. Did I look at this yet? I did look at this policy already. I should have had this running while I was chatting. We need to run this for a little longer. Yep. 10-minute run. Okay, number to beat is 86% with 3.3% collisions. Let's see if we can get that to work. And I'm going to Neptune. Also, I see next algorithm uses less hypers. So Gamma's the horrible hyper, right? Gamma's the really, really awful one, because it implies a fixed horizon. I will say that on fitting hypers, like, we kind of just made the hyperparameter tuning algorithm better, so it's not as much of a problem anymore. But the problem with using less hypers, right, is like, you typically can always design, for any algorithm that you design, right, you can always make it better by introducing more hyperparameters because you add more degrees of freedom. That's the tough part. So, like, basically what you could do, right, is you could define a new algorithm. You could define a, like, awesome advantage or whatever. Is just generalized advantage estimation with gamma hard-coded to 0.99 and lambda hard-coded to 0.9, right? And now it doesn't have the hyperparameters. But, like, generalized advantage estimation with proper tuning is always going to be better. A lot of the, like, the no hyperparam algorithms are actually just this in disguise, right? Where they've just kind of, like, stripped away degrees of freedom, set some reasonable defaults. Even when it doesn't look like they've set constants, usually it's like they've set a constant to 1, basically, so it cancels. That's the tough part. That. So I would love to have no hyperparam RL, but what I've kind of seen, it's like a little tricky. Now we absolutely do need to come up with something that's not gamma. Gamma as a hyperparam has been a disaster. Um, they're not differentiables, the problem. Now using carbs. But at least we have something a little better than carbs now, right? We've got protein. One of our improvements in 3.0. Problem is a lot of the, like, the hypers aren't differentiable. Generally very difficult to make the hypers differentiable. You'd have to switch the comparisons as well. Because basically, if you're going to fit those hyperparameters online, like, the actual training run that you do is going to take longer than a well hyperparameter tuned individual run. Comparisons get very fiddly. It's not that it's a bad idea, but you're going to have to be very careful with how you define everything. Just go up and then back down. Yeah, so this was like doing better, and then it kind of did this. 500 some odd mil. At AI. Yeah, we're working on that. Actually, I'm gonna probably, as soon as I finish this, I'm gonna be hacking on that. Um, the training is all puffer, you know. Yeah, this happened. Guess let's check perf. Oh, perf is actually a bit more stable though, right? Like, look at this. 2% higher, trending upward. It's collisions. Yeah. Collision rate should be going down faster than this. But we still have some knobs to do other things. Well, I don't think that this did very much, which is actually not terrible for us because it go back to a more reasonable step count. Okay, I mean the racing policy is good, right? It's like super snappy. I forget to randomize the drones. I did randomize during. My Whisker Racer game trained fairly well last night. 50K. What are you training it on? I'd have to see the stats. On a good GPU, you should be able to hit millions with Puffer. Yeah, so here's the drone racing with all sorts of different types of drones. It's still nice and robust. Sphere, right? This sphere. Cube. You guys make pretty close. Now that's pretty darn close. How much of a flag do you guys make? Recognizable flag? Just about a recognizable flag. Track made with JPEG and Ray. Yeah, you kind of just want to draw a bunch of curves, probably with Bezier functions. Probably just want to draw a bunch of curves, man. Not do that like loading stuff. Definitely don't want to be bottlenecked. Not a fun place to be. Especially because if you try to scale anything, like even more bottlenecked, because then you have more GPUs to your cores. For really fast M's are nice. Okay, so go down to a 500 milli. Steps. Now, there are a few other things I wanted to do with this. So I'm going to add the computed reward here. So just shy of 10 rings. 0.85 per. Now this should actually make the racing policy a bit worse on paper. Because it'll tell the drones to not crash into it. At the moment, they're told to not crash each other when swarming, but the racing one, they're told to do whatever. We're going to see what this does. Great, garbage error. Clearly no usable error messaging. Yep. Python tool. Bad. Oh, we're way, 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 way worse on perf now, huh? Well, that's funny. That totally crashes training, huh? It's actually, like, better at some. Weird. But you know what? Maybe it's not bad. Hang on, maybe it's just a difference in logging. Difference in logging. They look a bit more spread out to me. You can obviously improve observations and similar, right? But here's a little worse. Cube. Worse. Generally, mostly a little worse. Hmm. Definitely makes the test harder, right? Kind of did the data mix arbitrarily, didn't I? Do you think we still get the same problem if I just do this? I think we're not going to get a good racing policy if I do it this way. The idea is like, what if I just do strict random over tasks like this? Maybe you don't need that much for racing, who knows? And totally mess up the rings past match. Looks like it's not learning the racing task at all yet. Got good collision rate. Almost like up to the same purpose, but well, I guess it makes sense because the reward function is kind of fundamentally different, right? What do I do about this? Do I'm gonna try one more thing, even though I hate doing like these experiments. I think this is like a 2-to-1 ish ratio. Please add information about what we're trying to do here. I think I have. Did I add the links to the YouTube? I thought I had links added automatically to my description. Yeah, we have links, don't we? All the information's on puffer.ai. It's all like live reinforcement learning dev. At the moment, this is working on simulated drones. Get this to train and I'll say a little bit about it. What I'm trying to do at the moment, right, is I have a neural net that can train drones to do swarming formations, and I have a neural net that can train drones to do racing. I'm trying to see if I can get one neural net to do all the different tasks. It's been a little bit tricky, so a bit tricky. See if this actually. It'll be pretty funny if this doesn't work. I basically just guessed my first try how to mix the tasks, and I. It looks like it is at least getting some signal now. Yeah, okay. So it's at least learning now that with a quarter of the data on racing and 3/4 of the data to swarming, it actually does at least learn the racing task a bit now. Interesting, thank you. All sorts of fun research. Perf's messed up. Curious to see what the heck type of policy we get out of this. This backwards? Backwards. Yeah, it would be. Oh, it is backwards. Totally backwards. Well, get a very good racing policy with 3/4 of the data on, obviously. Just hack something real quick. do like this. I think we're getting the rewards blended up too much. This isn't even necessarily reward design, it's just the fact that like the rewards don't really line up too nicely across different objectives we have. So the only reason this is a problem is you're doing multi-objective. Yeah, but with a quarter of the data, we're still not learning. Huh? I figured that this would learn. I wonder if this is a problem where we can use bigger batch sizes, because like we have all these different tasks. Maybe it is something that can benefit from very large batches. Actually, it is starting to learn the ring task. Okay, so in the meantime, while this finishes training, and it looks like it's finally caught on, give it the penalty, I think. Needs to get the distance penalty or the collision penalty thing. Regarding Turing machines able to solve four-digit addition, nicely done. I actually don't know what that looks like in a Turing machine. How many operations is that? Gets to 76 perf, like 2.8 rings, right? See if this helps or hinders. Any binary operation. Had an operand. Second one operand two. Yeah, so it actually, I mean, it takes a while to discover that, I'd imagine, right? Okay, so interestingly, this improves performance, but it's no longer learning the ring task at all. Not at all. Straight ahead on the. Yeah, so that's like combinatorial, like, self exploration. Kind of brute force it a little bit though. But just barely got a little bit of ring reward up. Forever to learn this. Yeah, I would expect so. Sounds like it should take forever. Is there any other way I can bring this drone ring reward in line with the storm reward? It's a little annoying because, like, you have to go, you have to hit the target from a specific direction. I could make all of the objectives have a specific pose, technically, right? It's a little difficult though when it's like stationary versus fly through target. If I just do two policies, it's a lot easier, isn't it? Let's play around with the getting like irritating. Let's play around a little bit with Congo is a very hard task for a swarm. See if it can do this. Hey, the vectorization is stuff. For variant of DQ, place the traditional relay buffer. Go max out heart pole. Okay, cool. Let me. I'm trying to think what a good problem would be. I'm not gonna want to be doing this stuff in a notebook for very long. I can tell you that. Probably like breakout or something. Maybe you have to start with Pong. Pong is faster to solve. New to this field, and I'm learning data science. Never worked on RL. Can you talk about the metrics on right? So the metrics on the right are a whole bunch of losses. Um, they're not actually all that useful in reinforcement learning. Pretty much, they're not supposed to explode. If they explode, they're bad. Like that's bad. Ones that I do occasionally look at. So entropy crashing too low means the policy is taking deterministic actions. Really bad. Clip frac being too high. Your policy is making gigantic unstable updates. And yeah, the rest of them generally just not blow up. Otherwise, you have numerical stuff. You've seen this error before in eval, but not in train. Helping debug for someone else. I use eval, not. Yeah, Spencer, it's probably if you look at the way the actions are being sampled, they're probably like not an array or not the right data type or something. If you change like the data type or you change like maybe it was like a numpy array and like they added an extra dimension or something, it'll break. API usage error means that you're doing something wrong. Just like print out the data types and shapes before and after. What are they doing with the action space? Changed to different ones. I had 13.7 and now we're going to. Are you loading one policy, like a policy that's old, that's like outputting actions that are outside the range? That'll break it. Not perfect, but pretty dang good. See what this looks like without randomization. 94, just do better without randomization. If so, then we can use that as our like hard task. ID. What was the issue racing? So basically for any of these tasks, we can get any of the individual tasks to work on their own. We can get racing to work on its own. Get swarming to work on its own. It's just trying to do all these tasks together with randomization and everything else is hard. Actually, that's probably what I should do next is I should try them jointly without randomization. Interestingly, this doesn't seem to do any better at the moment. Generally, the non-randomized train initially. It still has half this. I think we'll try to see if non-randomized actually works across all tasks next. That'll be decent. How goes the grifting? I thought you weren't on Twitter constantly, Ryan. How's it going? When are we doing NetHack AGI? Still waiting on my. When are we doing NetHack AGI, man? Offer coin T. Yeah, FYI, folks, none of those coins are real. Like a lot of people keep making fake coins like labeled puffer. There's no coin. I had jury duty. Got sick, so big dud. Well, that sucks. Straight to jail. Do not collect $200. Not pass go. Straight to jail. Interesting that this doesn't seem to be much better, but we have all sorts of cool new stuff that we're starting though with puffer days. We're starting to actually figure out some cool applications as part of science. But better. I'd have a day or two to start before RLC, and then a week after. Canada. Oh man, that's rough. No barbecue for you. Is there a thing where like is RLC the conference where everybody has talks or no? Or do I just have to make a poster? I think I should just have to make a poster, right? Or is there talks? We all have 8-minute talks. Oh great, so I gotta figure that out. That'll be a problem for me next week. Okay, I mean this is visibly like slightly better. It's not perfect. Drone Congo is very Congo. Like the drone Congo. Chalkboard poster. Puffer poster. This is a decent enough task on it. Okay? Puffer and syllabus. Yellow and now at our yeah. I'm done. I'm done presenting like well, I'm done publishing. Too much of a pain. Think of it. YOLO some learning programs. Yeah, this is true. The growth on Puffer lately has been absolutely great. Like Your how's your new advisor on here? 8. All right, I'm more than halfway there, man. That's how it works, right? When you get more Twitter followers, you become the professor. But yeah, like the Puffer's been almost at 3K stars on it too. Working on it. Get like 10 likes. Yeah. Well, it has to do with density, right? If you post about a bunch of different topics, you don't have the density. I pretty much post only RL, and like usually when people post random dumb funny stuff, it gets like more attention. With when I post random dumb like stuff, it gets no attention. It's like the entire audience is just there for the technical RL content. Kind of awesome. Like even the normal like oh big company bad stuff gets no attention, right? Literally just the pure technical content. Kind of great. Well, I want it to be even easier. It's just I can't spend all my time on making it easier because I also have to spend time on like solving stuff. Church. I mean, I really just care about making RL work as a field, so I don't mind doing all the engineering and stuff. I do mind having to deal with Python's packaging for that. Python's packaging is okay. So I reduced us to a smaller network, and now we're training it up to 4 million steps per second. It's still almost same perf. 9.2. Go. Need to really make it just compile one env at a time because it's ridiculous. Add that, it wouldn't take that long. 9.3, 2% collisions. Okay, almost identical. So we'll stick with the small policy because it's easier to deploy anyways. How do we improve this? Let's go. Go take a quick look at I mean pretty good. Curve. These aren't comparable. Pretty good train curve. I wonder if it's somehow more stable. Can I just literally do this and have it work better? my training. This is okay. This is randomizations on the Congo task. Probably the hardest of the swarm tasks. What else we could do with this? Word signal should be very good. Could return very, very low. Really tempted to. Maybe I will try that. This would return is like. I don't know if that even matters. I'll use standardized advantage. I think it's. That hack is gonna be cool, I think. It's it's the type of thing where we're gonna have to definitely run all the speed tests first to make sure it's actually feasible. Like if it's below 100k, below 100k is not fun. Honestly, I'd like to have it at 1 million if we can get that. It's supposed to actually run at 1 million, isn't it? You can actually just get the data from point A to point B fast enough to run that faster than it. There's like no reason that game should 100k. Like old school C. Have you ever just gotten like the low level interface and run it in a for loop and seen how fast it is? Conditional checks don't matter. CPUs love conditional. We have tons of them. Full if statements are slow business. Invention of jacks. Figure it out real quick. This crap is definitely slow. We're gonna just delete all the end wrappers. Out the rent wrapper, yeah. All of these like spaces things, they have this super messy space. Like you need to not even you can't like you need to not even grab and like be copying all this to only grab the stuff you actually need. Ideally, you would start with the minimal set of observations that you get away with, make it really fast, and then what else you actually need there. They have like 1,000 for loop here. Of like what this is. Like just a lot of Python. It's just they have a lot of Python that's kind of eh, like lots of Python. It's set gym space to 4 and 3. 3 is appearing in their second act. Seriously? Well, did they change the action head? Like hard coded. Shouldn't be able to have a 3. Word scale makes a meaningful difference. They get to almost not reward scale being observations then. I focus on poster editing if you all my work done in time, starting to hack, bro. How do you have how long does it take to make a poster and a talk, man? I'm allocating like 2 days for this. Max. Making posters is boring work. No fun. Well, okay, let's just do figure out comments near velocity. Polish syllabus. I see. Okay. Moving to Canada. Yeah, sounds good. Let me know. Solve all the things. Do we really think that it's like observations needing to be rotated or some weird thing? Not just be able to learn this. Maybe it can't. To be fair, we have these like really shallow nets, right? Wait, come on. Alright, you know that things are stupid when I'm like starting to actually mess with this, but we'll do it anyways for one. Why the hell did I just do this on dummy? I don't know why that. The drone, right here. A mess of all the time. Help me with RL project. Um, we have a whole community of people on Discord. If you're like new to RL and getting into stuff. Okay, so what have to add? Like add. Discord.gg/puffer. I just want to see if it's like a dumb model capacity or depth thing. Like I kind of forget that we use tiny little network every so often, but I did actually catch one like oversight in Puffer with visualization. Good that I happened to look at this. I don't know if it makes a huge difference to anything overall, but it is a difference. Funny enough, this actually does worse so far. Distinctly, right? Probably like over optimization at this point, I guess. I'll rerun this just to be sure because this shouldn't make it worse. Optimization. I'm gonna play with a few more things before I just like decide that manually fiddling with this is not a good use of time. Give yourself a little bit of time to tinker with these. Looks like a better curve, right? At least this is closer to the percent on the end. Tried making upper lip stuff for RLM loop, LLM loops. No, kind of do everything except that. Models are just so big and clunky. Like there's really nothing you can do with them. Stupid amounts of compute. This only. Oh wait, max mini batch or now we're at 5 million steps per bigger batches. If this makes any difference. Yes, it's like slightly worse. Far nice and consistent, but like slightly worse. It gets to the same spot though. I'll take it if we're gonna get the same level of perf. Oops, level of perf faster. Hypers just have not been swept in a long time. Realistically, that's just going to be the blockers until I sweep the hypers. Like, find a stable way to sweep the hypers. Not going to be a ton I can do with it that's better than this. Let me just try the defaults real quick. Like, you literally... You never know, really, in RL. To see if there's, like, something to this, right? I don't think this will do anything. It's worth trying the default. Way slower, holy. Forgot about that. Try this next. Just tinkering experiments. After that, we'll say, okay, I tried all the obvious stuff. I'll have to just automate some sweeps and figure out how to make them stable. Here's a restroom real quick. I'll be right back. Alright. Okay, these defaults didn't work at all. Why would the mini batch size bigger? It's reasonable perf. I think I'm expecting this to do any better, but every so often it's like, hey, you go and you fix your problem and defaults work. Worth checking. If not, we'll just figure out how to set up a sweep that doesn't crash. Lower. Hard to say if it's like actually plateaued or low and unstable, right? Sure, this one was actually. Hyper's just probably doing too much tinkering here. And in fact, if I knew that the sweeps were stable, I would have done that and been done. Always invest more in it. Not great. We'll see how that goes. A whole bunch of small changes to add here. Actually, I don't want to run that sweep on the box. I get it set up on the other one. Alright, so we'll see how stable this ends up being. Now we're not going to have this box monopoly. I need this one. This is the fast box for meta. I have no recollection what the last date of this was. See? It's like a reasonably quick turnaround time for this. Cool. Oh yeah, there's Lila's cool. Alright, so this is training, right? So the fun problem we're gonna have is I'm gonna merge this, and we're gonna have about 50 million commits worth of insanity. Or at least a version change. So apparently I ran 5 bill at some point recently. Got a bunch of hearts. We're just gonna see what the latest thing pose. Yeah, the config's totally changed and got differences. I actually don't know if this one stick with this for now. The reasonable baseline to work. Might clipping a bunch. Looks like it could be. Oh, how the heck? It got knocked over. Weird. When I did that. Could be better. Okay, so this is actually working very well. It keeps going right up. If I go to sync this, how bad is it going to be? 357 commits in like a month. Great. Okay. We're gonna have the before and after at the very least. As closely as we could possibly have it, we'll have the before and after. $7 minutes is not too bad of a, not ideal for dev loop, but enough. Okay, so 6 hearts, right? Basically, what we get is hearts. I'm gonna have to reapply this. NumPy Gymnasium that requires. I'm gonna remove the ones that I know I already have. I have like everything way too aggressively pinned, I think. That's my bad. Being weird. I don't know how it always corrupts their first character. And everything's moving around again. Great. Okay, I remember at least what they did here. Huh? Wait, what? Why is this in site packages? Oh, I know. That's fine. That. What the heck is all this? Configuration changes, I suppose? Go see what their new config is. Comment on why you think writing C is better than Jax. Jax is quite simple. So here's why. You have to express all of your logic in terms of array operations, right? You're really not writing Python. You're writing a domain-specific language that's forcing you to express all operations in terms of arrays. So you can't really just write like arbitrary branching logic like you would like to be able to. You can sort of force it into that if you really want to. And then that gets to be slow because the GPU has to execute all parallel branches. And then you have to be very clever to work around that to reduce the number of parallel branches. Uh, to do so is essentially to solve a massive puzzle because this is not general programming. Like, you're no longer really doing general programming anymore. And what do you gain from doing this, right? Okay, your env can run on the GPU. Why did you want to run your env on the GPU? It was because it was slow. Why was it slow? It was slow because it was originally in horribly unoptimized Python. So what we do instead, right, is we just write really, really basic C. It's much, much easier than writing in JAX because we can just write arbitrary logic, right? We have no restrictions on branching or conditionals or anything like that, or like restrictions on having to use a large number of envs for the GPU to be efficient. We don't have any of those sorts of restrictions, and we can just write whatever we want. But like, okay, so even if you can technically express your thing in arrays with enough work, why would you want to do that? The only use case really is if you are doing heavy physics sim and writing some sort of like tensor-based engine, fine. Right? But if you're doing anything else, like why would you want to have to write everything in array operations versus just being able to write arbitrary logic? The only answer I can come up with is because researchers are allergic to writing anything that's not Python. Even though really JAX is not Python, it's a domain-specific language that happens to have Python-esque syntax. But it's really something quite different. Like it's way, way, way harder for no real reason than just writing some basic C. Obs and actions are arrays. Say they're tabular. Yeah, well, wouldn't you like to be able to write arbitrary logic, though? I mean, so neural MMO3, for instance, is like that thing runs 1.5 million steps per second. It's a miniature MMO game, right? 1.5 million steps per second on one CPU core without us having to do any weird array operations. Even though, yeah, we have all sorts of like array like data structures in there, right? But it's not all arrays. There's also branching logic and stuff on top of it. You just never have to deal with it. If you're using an actual programming language, right? If you're actually like writing something that is a full programming language, it's not a domain specific language. Just have it work. Look, there are totally people that are like, "Oh yeah, we're smart. We can make it work in JAX," and that's cool. But like, you could also just use a full programming language and also have it work and also have spare time. It'd just be much, much less painful. Yeah, exactly, right? Like, it's literally the reason that people do this because they're allergic to not writing Python. There's no other reason. scary. It's really not though, because I have brand new programmers doing this. Like if you look at the code that we've written, it's like first course in systems level C. Like a freshman undergrad who's taken their first systems course to do this. Like frankly, writing jacks, it's way harder. Like what you're forcing yourself to do by writing M's and jacks is way, way harder than just writing some low-level code. Like once you actually write some stuff and like just start doing a little bit of low-level dev in this, you'll see the difference. It's like, oh yeah, that's insane. Yeah, sure thing. Isn't that bad when you have a template to start from? Yeah. Well, honestly, the worst thing about this C is like the bindings to Python because that API sucks. But we kind of have to like that's just taken for care of for you. And if you really want to know how it works, like you have one file to read that's it's like several hundred lines, but it's not gigantic, right? It's mostly just a bunch of Python C API glue. It's nothing like it's really nothing that crazy. Yeah. You do need to understand pointers because otherwise I mean not teaching pointers is kind of just as much of a problem because then like all the structs are copy on pass. So like everything is immutable essentially, which is not a good thing. If you write like immutable C, you're going to lose a lot of the performance benefit of writing C. It's like a very like functional thing. Not a good idea. But tiny grad, well, it's not faster on Nvidia hardware and won't be for a while, right? Like it's slower on Nvidia hardware, like because it's still early. They're mostly doing alternative hardware at the moment. If you have Nvidia hardware, it's like kind of too early to adopt any, like to look at adopting yet. It's a cool project. message, guys. When will we see ML move to the true best language, Rust? Yeah, I hate Rust. I do not enjoy Rust one bit, man. Okay, here's the thing with Rust, right? The whole freaking language is designed around this borrow checker, which makes you structure all your code differently from every other language. What is the point of this? You avoid one class of error, right? You avoid memory leaks, basically. You avoid one class of error that was never a problem in the first place. So no, piss off, Rust. uh, God. Look, C has its problems, but it's Rust leaves those problems in and then frickin' makes its own problems. That ain't the fix. That just ain't it. Just to avoid memory leaks. I mean, look, there are probably some other bugs, I guess, that you can catch, but like, fundamentally, I think that most of the things that you're trying to do at a language level are just done better as debug compile options. Um, like mem leaks aren't really a problem. Typically, it's out of bounds writes and reads on arrays is the biggest one, but like, you can just use an address sanitizer. Like the address sanitizer kind of fixes all the problems that force the user to write different code in order to attempt to solve with Rust. Like, how do you make Rust fast, anyways? You immediately start writing unsafe, anyways. Look, it's like fine if you're doing embedded systems dev where you're really worried about these specific classes of errors. Stuff is really fiddly, but like, it's being massively overused. It is just like so easy. It's just like it's just so easy. Hey, welcome, Boxin. Are you gonna be on stream for day? No idea. Probably until I figure out environment plus a few other things. Oops, actually, I just saw. This actually might not be a bad time for me to go take a couple meetings. I have a bunch of messages. I'm mostly going to be waiting for the meta guys to reply on like where they've moved everything. This checking out your PPO implementation modifications. I've checked our what? Vector implementation differences are the advantage, parameter sweeps. So it is muon is a big one. Trajectory segment level advantage filtering with prioritized experience replay is another one. The new advantage function is another one. Sure, I missed a couple, but the rest, it's like all in the blog post on X as well. Discuss papers late. Around 6 hours. You should get more than 6 hours of sleep in general. I would highly suggest that. The 6 hours is like 8-ish. Maybe can just if you message me later in the evening, I might still be around. It depends. I gotta go to sleep early tonight though, because I gotta get up early for SF trips. Long day. All right. Well, get some rest, man. I gotta go take this meeting. So the folks who've been tuning in, I will probably be back afterwards once I finish this, and then the meta guys reply and tell me where they've moved all the stuff around to. We'll probably be working on getting this env training nicely with their new code. For anyone who's new here, I stream all my research. Sometimes we do fiddly optimization stuff like you've seen. Sometimes we make drones fly in sim in really cool ways. I just stream all the dev. Interested in my work more generally, at puffer.ai. You can help me out for free by starting the repo. We're almost at 3K stars. Want to get involved with dev, join the Discord. We've had a huge number of people join this in the past couple of weeks. And yeah, you can follow me on X for all those resources. Thanks, and I will see you around.